So, first we will be talking a little bit on the background, on the setting of the geological setting for London. Then we will cover the main basement developments. We will talk on common risks of of those developments in central London. Specifically, we will focus a little bit more on heave assessments, ground movement assessments, and future approaches and improvements that we can talk on. Yes, so a little bit on the geological background of for London. Superficial deposits. The London geology consists of, it does contain alluvium. That's usually a silty clay, probably more 4 meters thick. It could include granular material, could include cohesive, it could include peaty material. It's often very soft, highly compressible. People obviously know about it. It's usually around the Thames and other watercourses. Varies in plasticity. Usually it has volume change potential and it could be high. We do have head deposits. Head deposits are not always mapped, so there may be head deposits which you may encounter and to some depths that you have to take into account after you find them. Typically they are about 2 meters thick, they can be more. They do have volume change potential and they're often followed by a London clay formation, which is the bedrock. We do have Langley silt member. This is again a soft, let's say, layer. It's not always cohesive, so it could be partly granular as well. It is of limited thickness and it often has volume change potential. People try to avoid this in construction. The main bed is the river terrace deposits, usually consisting of sand and gravels, with localized cohesive bands. Typically they're less than 10 meters thick, even less. Usually they do have a saturated and an unsaturated zone. They do contain some water at the base of those formations, and they are capped by significantly cohesive deposits like the London clay. The majority do not have volume change potential. However, in some areas, those cohesive bands may give you that volume change potential. Right. The bedrock geological formations, I will briefly go through those as well. We have the Buckshot Formation, localized, sometimes in North London, close to Camden. That could be granular. It often has volume change potential. We do have the Claygate member and the London Clay Formation. Sometimes you do get the Harwich Formation locally, and then at the outskirts you do have the exposure of Lambeth Group. Then you have Saneth formations, and outcropping at the edges of London you have the White Chalk subgroup. So chalk lies beneath those formations. Central London is dominated by the London clay, and we usually get a lot of projects that they do have to take into account the properties of London clay. That's basically the main formation that you will find in central London. Yes, this is for reference a geological map of London, and we can see the different formations here. Following the River Thames, we can see the alluvium and London clay, the river terrace deposits around, and exposed chalk on the southeast. Talking a little bit on the hydrogeological setting for London, this is the different aquifer classifications that everybody's familiar with. We have principal aquifers, mainly associated with chalk. However, you will not find that in central London easily. And usually you do have your superficial deposits consisting of secondary aquifers, and you have unproductive strata, most of the times connected with thick cohesive deposits lined like the Claygate member and London clay. This is the aquifer designations in picture. Yes, we can still do the connection with the rivers and the river terrace gravels, as well as the chalk around, which is exposed. A little bit of talking on the basement developments. So basements, and we do not really talk today about really deep commercial basements. We're talking about domestic basements, about 3 to 4 or 5 meters deep, which usually are in the forms of underpins, and they can be underpinned from existing buildings or existing cellars or basements, or they could be new developments. The construction method may vary, and you can have mass concrete retaining walls, you can have embedded walls like second piled walls, contiguous piled walls, and other methods of construction that will obviously change the way that you will approach the project. A typical construction sequence in a simplified version is those 4 main steps: is excavation of the retaining walls and temporary works. Then you do have the construction of those walls, mass excavation. Most of the times under underpins, it could be a hit and miss approach. And then you have the slab construction and the final construction of the basement. These are the simplified versions of how the engineers are trying to approach the several geotechnical aspects like ground movements and other considerations in a staged approach. The basements are usually are complicated projects, and that increased complexity may result in more consideration for auditors, planners and councils, usually making the project a little bit more difficult to agree on. However, the purpose of this presentation is actually to discuss several issues around those aspects, so that some considerations could be more streamlined, I would say. I will go now to a basement impact assessment. What is a basement impact assessment? It is a document that uses desk-based resources to assess the impact of those developments on the surroundings and the geological setting, as well as the opposite, the impact of the actual setting to the construction of the basement. It contains, usually the bulk of that contains 3 parts. You have initially the screening assessment to identify the risks. This is a streamlined version of a geotechnical desk study. Each council in London have their own requirements and their own screening assessment process. Then you do have the scoping assessment, which actually identifies how each of those risks will be assessed during the site investigation and how you should design the site investigation. And the final version will be the recommendations, which is after the site investigations, and how are those risks taken into account and tackled, let's say, by all parties. I will talk a little bit on the common geotechnical and hydrogeological considerations around basements. We have groundwater and purchased water and the effect on flow or flooding. We have considerations for surface water management, seasonal soil moisture changes, volume change potential, trees. It's the usual things you have in construction. However, you still have them in basements. What you do have here, and it's quite an area that it is actually a requirement that you have to do, is about the pressure-induced settlement and heave. And this is where those stages are coming in, and how people approach those stages to produce those settlements and heave. Instability during excavations, ground movement, and impact on surrounding buildings and assets. That's a whole separate section, which is the GMA, or the ground movement assessment. And we will touch base on that later on. And this is mainly how the surrounding buildings will be affected by the excavation and construction of the basement. You have the usual aggressive ground conditions issues, like sulfate related. You may have a slope, and in London, you do have tunnels and underground assets, which may escalate your project to a different level. It's obvious that screening, scoping, and addressing all of those issues require a very good cooperation between the geotechnical engineer, structural engineer, architects, and hydrogeologists and other, so various people from different backgrounds will need to come into, to have an input into a BIA so that it is properly assessed. I will touch base a little bit on common contamination related issues. We will not talk further about this. I just wanted to present a little bit on that because it is a little bit of a hot topic right now, and especially with vapors. So we have obviously the soil contamination, groundwater contamination, but because basements are underground, confined spaces, we do have more and more issues with vapors and probably radon ground gas that you wouldn't probably have on the same area, on the same setting without a basement. So this is something that is currently a hot topic, and it will be a hot topic for the future. And as far as contamination is concerned. Common flood risks, in addition to fluvial flooding from rivers and seas, obviously you have your flood defenses. Basements are underground structures which are, we have to consider surface water flooding, we have to consider side drainage, groundwater flooding, we have to consider, and this is another hot topic which is emerging right now, is that it is there, it was always there. It's more about a consistent effort is made towards addressing better the groundwater flow and the impact at a greater scale of the basement towards the groundwater flow of the entire area. And Rob will share a little bit more on that later on. There are recent studies which actually, they're big, large-scale groundwater monitoring investigations across London, across boroughs, and they do tend to find out the actual risks at the local scale of how the building all of those basements, how that those densely populated areas will affect the groundwater flow within those seasonal aquifers that we saw previously above the London Clay Formation, for example, and how this affects other areas down the borough, flooding those areas in an accumulated way, combined with sewer systems. So you have sewer flooding, you have groundwater flooding, surface water flooding, all of those combined together. You have those critical drainage areas, local flood risk zones, which you didn't have in other areas or in the past, which are increasingly going to be a major issue in the next decades. Yes. I will move forward, and Rob will talk a little bit more in depth about the uncertainties and how do we need to approach those issues as food for thought.
Thank you, Miltos. So what Miltos just spoke about was basically all of this, the screening stage of the BIA, where we're looking at these potential risks. And now what I'm going to be speaking about are some of the uncertainties when assessing these risks based on data we have, the methods that we use, etc., etc. Not us personally, but globally, because there are some issues which will go into greater depth with throughout this talk. So firstly, I'm going to talk about just some flooding and water management. So a few assumptions that are often made is how are there any basements surrounding the areas, surrounding the property itself, and how deep are these basements? You can get that information from maybe structural engineers for the adjacent buildings, but some of this information is hard to get. Then there's also without very complex hydrogeological and hydrological modelling, how do you assess the cumulative effect of adjoining basements in terms of groundwater flooding, because they can act as an obstruction, much like how are we going to assess the obstruction effect of the actual proposed basement? That's another thing to look into. And also, how is climate change accounted for? Obviously, we've seen in the last few years, London can get under quite serious amount of flooding, from quite flashy floods in the summer to quite prolonged ones in the winter. So our climate's changing and we've got to adapt to this. And other areas which Miltos touched on briefly was regarding critical drainage areas and local flood risk zones. I think Richmond Borough Council call these areas wards. And these are basically areas where there's very localised flooding, where all of the flow paths lead to these areas and you have specific risks there due to various different types of flooding, be it sewer flooding, groundwater flooding, surface water flooding, etc. And each of these different areas has different sort of characteristics. You could have one in Camden where there's very shallow London clay, and therefore there's not enough that you could get rising groundwater or perched water on top of the London clay, just because it cannot drain anywhere. And that could lead to sort of groundwater flooding and obviously surface water flooding. Whereas in somewhere like Westminster, where you have gravels over clays, there's obviously an aquifer there, and again, these could any basements can act as obstructions to the flow within the aquifer. So there is, even though there's only a few geological formations within London, the issues revolving around it are can vary quite a bit from site to site. With regards to flooding. So next we'll just talk about the settlement and heave analyses. Firstly, it's regarding the amount of SI that we do. Is it acceptable? I know different boroughs have different amounts of boreholes that are required to be drilled. And is there enough information? Sometimes if you have limited access, you might not be able to get a more powerful rig to drill through really dense gravels and find the clay, and therefore you wouldn't be able to install a well and properly assess the groundwater, which could lead to encountering groundwater when you're excavating. So there are issues there, and then we also have to think about the geotechnical parameters and the methods that we use and how we derive this data. Do we use literature? Do we use SI information, lab tests? Normally it's a combination of all, but this doesn't mean it's completely perfect. And then there's also a degree of conservatism from your SI information based on industry standards and things like that. So that's another sort of uncertainty and potential conservatism. And next, this is where sort of good communication with structural engineers comes into play. We need to know how the basement is going to be constructed. If we can get a construction method sequence from them, then that's great. And we can try and tailor modelling to be in accordance with that. But you can't model absolutely everything. So where it's sort of a balancing act between efficiency and sort of how much detail you want. So it's that balancing act. And another thing is to look at how when it's actually come to construction, how in alignment is the actual construction with the construction method sequence and the modelling, specifically with depth. I believe in some London boroughs at the moment, there's even people, sort of auditors walking around and making sure people are sticking to their construction method sequence. And if they're not, they're told to halt all works and completely stop, which obviously can cause delays, expense, and a whole host of issues. And then there's another sort of side note where we're just touching on sort of the methods that we use. Should we use finite element analyses? Should we use empirical formulas and that elastic analyses? There's a lot of different analyses out there, all with their own pros and cons. Some it could be very detailed and you may have a large margin of error because of the amount of detail. Some may be oversimplified. So yes, it's all about what's the most applicable way of modelling for your specific project and issue. Now we'll move on to something a bit further away from what you can do and more what you can use from, there's ground movement curves in the Syria C760 document where there's quite a lot of data, but mainly for stiff clays. So for example, as you can see here, there's no ground movement curves for excavations in sand or installation of walls within sand. There's no vertical ground movement curves for installations in sand. There's limited horizontal and vertical ground movement curves in stiff clay. And there isn't an official ground movement curve at all for installation, horizontal, vertical excavation for more soft clays. And therefore the data does vary significantly. And it does, and the way that the ground is displaced and settles away from basements and installation of basements varies a lot between sands and clays and different densities. So, and moving away from the geology and more about the projects that we used as case studies for this research, they were much larger than the typical residential basement developments that are being used for at the moment, that are being proposed at the moment. So we're kind of using quite conservative data as a whole because the excavations and developments are much larger. And also touching on that, they're also for embedded walls and not underpinned walls, and we'll come on to that a little bit later on. And another point of note, obviously this depends on what analyses you're doing, but should pressure-induced movements be incorporated into a sort of a ground movement assessment, so basically the previous slide where we talked about settlement and heave analyses, should the resulting displacements be used from those models in your ground movement assessment models? And now moving on to the ground movement assessment models themselves, there are some, but based on the type of modelling that you're doing, what ground movement curve should you apply if the geology varies? Obviously, if you're in sands and then stiff clays, which could be the way in some of these places in London where it's gravels over clays, or you may have softer firm clays like head deposits over London clay, much stiffer. What ground movement curve should you apply? Should you apply a softer firm curve and be over conservative, or should you apply a stiff clay curve and be a little bit maybe not conservative enough? It's kind of a balancing act between, and a lot of engineering judgment comes into it. Another thing is, how would multiple excavations interact with each other? Or if there's a re-entrant corner within a basement, which is basically if there's an L-shaped section and you have, would there be a lot of settlement basically because it's away from the two faces of the basement? Will there be a lot of settlement localized to that area? If we do just a standard analysis for that area, would it be over conservative? Another thing to consider is how a slope's accounted for. This is mainly referring to sort of assets that are away from the basement. They could be higher up on ground higher up, or they could be on ground much lower down, and that may have an effect on the results. But some assessments you may only be able to model everything on one level. So again, it all depends. how does the impact of subterranean structures, such as adjacent basements, how are they accounted for? Because they could offer some, I can never say this word, but rigidity, and they could solidify the area. And because they're large concrete structures, they're obviously a lot less mobile than sands or clays. And similarly, how is the foundation depth of surrounding walls accounted for? Because again, if you have a deeper foundation, then the differential depth between the basement and the foundation, that would be different. So just assuming that one wall is at 0 meters below ground level and the basement's at 4 meters below ground level. And also, if you have walls, i.e. the front walls of terrace buildings, they may act structurally as one. So do you assess each property as their own, or should you assess the entire front walls of the terraced row of housing as one wall? And another quite hot topic is how are party walls assessed, or walls 0 meters away from the basement assessed? Because when using Syria curves, the graphs are basically along the y-axis, it's a function of the amount of settlement, and along the x-axis, it's a function of distance away from the basement. So how can you assess something and how can you plot it on that curve when it's 0 meters away from the basement? So again, there's some sort of confusion and discussions needed to be had on how to analyze those. And again, what assessment and software is suitable for the assessment? This could vary between company and company. So yes, so that's sort of some of the uncertainties about ground movement assessments. And here are just some concluding notes regarding ground movement assessments. You can usually end up with a lot of different cases and assumptions, and maybe carry out sensitivity analyses. You could end up having quite conservative results because of these assumptions. And therefore a high influence of engineering judgment comes into play, and rather than using just a universal approach based on the correct or relevant data, which, as we discussed before, may not even be correct and relevant because it may not be the correct geology, it may not be the correct installation of a wall based on the Syria curves, because the Syria data is quite limited. And lastly, shall we use overcomplicated models such as finite element analyses? Obviously, these are very powerful models, but you need to have sufficient experience with them and knowledge of geotechnical and structural parameters in order to model and analyze effectively. These also take a lot of time and they're quite expensive methods, and that cost will obviously be passed on to the client. So could you use an elastic analyses method, which are a little bit more simple? You only take into account a few geotechnical parameters and Syria curves as well. Or you could do empirical data and calculations yourself. So yeah, there's a lot of conservatisms and a lot of varying ways that they could be carried out. So other uncertainties, Miltos briefly touched on the contamination aspect earlier. If the investigation is mainly for geotechnical and the client doesn't want to investigate contamination, then how do we know that the correct membrane has been installed? There could be ground gases, there could be vapours. And I think a lot of London boroughs, RBKC and Hammersmith and Fulham, they're getting quite hot on vapours, and so yes, it's something definitely to look out for. Will swelling affect the serviceability of the basement walls? Will the heave below the basement slab from the overburden pressure release cause bending of these retaining walls? Another quite hot topic that's come into play in the last few months is about buoyancy of basements. If there is groundwater, what's to say that there isn't buoyancy effects acting along with heave? And should heave and buoyancy forces be accounted for individually or as one? And again, how can soil displacement cause bending on retaining walls? But a real important thing to say is how do we know the impact of good workmanship, and how is that being assessed? How is it being accounted for? Because good workmanship is so important in order to construct a basement and excavate a basement and limit movements to sort of acceptable limits, or at least the limits that were anticipated. If there's not proper dewatering or propping up, then there could be catastrophic effects. And again, inconsistencies between companies. You can get varying companies getting a whole different results just because there are a whole load of models that can be used and a whole load of different assessments that can be done. So what's to say one person's done it correct and the other person hasn't? It's just two different methods. So future developments, a real big thing is research into underpinned basement projects. I myself have been I'm on the AGS working group, for Geotechnical working group, and they are working with a PhD student from the University of Portsmouth who is looking into underpinned basement, the movements resulting from underpinned basement projects. And he's collating a load of data, and he's assessing and seeing how this differs to the Syria curves. And hopefully that could come around and be some really important information and could really push things forward, because at the moment we're looking at embedded walls when actually underpinned walls may result in a lot less movement. But that's hopefully all to come, and it'll be interesting to see how that develops. But whilst that is developing and whilst that research is going on, should there be a condition for local authorities to implement and ask for ground movement monitoring data? And should the local authority then pass on the data so that we can actually use it and for future projects? Because as we all know, I'm sure everyone's been to many of these CPDs and heard that data is the most important thing at the moment. And for basement developments, there are a few gaps. So in the absence of this data, could some informal guidance be produced? Could we use empirical equations at the moment? There's a few different routes we could go down, but these are all to be sort of discussed and agreed upon. I've also attached a website link there to an AGS, one of the magazines done by AGS, which actually discusses underpinned movements, and I think it's a really strong magazine article, and it's certainly good to read on that. So yeah, so we've now come to the end of our presentations, and we invite any questions and answers.